sure that you are turning in your water lab conclusions, please. Your write-ups are due for me. That's on the back side. So if you could please make sure your name is on your lab, and then just hand in that lab report so that I can read it this weekend. That would be great. My husband's going to the basketball game with his father and his uncles on Saturday, so then I'm going to be home alone. Yes. And I get to just sit and watch like crappy TV and like grade your lab. So I'm excited about that. So if you could please, if you haven't got them turned in, like if you're not done, could you please slide it underneath my door before the end of the day? I would greatly appreciate that. I'm not grading your lab, only the write-up. So if you don't have a write-up, you're getting a 0. It's just the write-up that we're doing.
You want me to rip it off the packet?
What?
Rip it off the packet?
No, you don't need to rip it off the packet. I'm just going to be looking at the back page. As long as your name is on it, please make sure your name's on it. All right, so after that, we're going to go ahead and talk about the water cycle some more. We have a lot to do. Don't get in the way of me teaching. We have a lot to do today, so I'm going to ask you please write down the question of the day. I'm going to be quiet for a minute. I'm going to ask you to be quiet for a minute so that you can go ahead and do some reflection, and I can go ahead and take attendance. So thank you very much. No talking, please, for 1 minute. Justin, you got to pass? 1 minute, please, while I take attendance. Sigh. Rebel, don't be so easy.
Thank you.
We have about 20 seconds, and then we'll go ahead and talk about what is transpiration. If you don't want to write the whole question, you just want to start it out like this, then start it out like that. All right, there is our time. Could you please turn with your pair chair partner and talk about anything that you remember as far as what transpiration is. And your time, we're going to have a 10-second countdown, starts now. 10, 9, 7, 6, 5, 4, 3. But that's what I'm collecting. That's what I'm collecting. Alex, that is not the Bolt's way. All right, 3, 2, 1. Sometime today, make sure you just slide it underneath the door. Turn, please, or how about we share that out? What is transpiration? Come on, this is like my favorite class, and y'all are like not talking to each other today. It's like really like bringing me down. What is transpiration? What do we got?
I don't know.
You say it. What's transpiration?
What?
What's transpiration dealing with?
What?
What did you say?
See what you guys are here.
Transpiration. Yesterday we went over a bunch of notes. Could you turn it this way, please? What? Transporting what? We are transporting water. It is about the water cycle. In transpiration, the water cycle is moving around because of what?
Gravity?
T for tree. So transpiration is water moving, this worries me, y'all, moving through the water cycle by trees or plants. Okay, so if you remember yesterday, we were talking about cohesion and adhesion. If you don't know this, by God, write it down because you're going to need to know this for the exam and a possible quiz we have on Monday. Transpiration, T. If you get stuck on it, think T for tree. So water is moving through the water cycle by trees. Okay, so what happens is roots take in water from soil. Water moves up through plants. Does anybody remember what that's called? Not transpiration, when it's moving through those little tubes. It was part of your lab. It's called capillary action. Remember the blue that went through the celery? Capillary action. Those are 2 words. Sorry, it looks like one. Capillary action. Okay, water moves through, up through the plants. Then water leaves the plant through pores, just like you have pores in your skin, in its leaves. Oh, that's weird, leaves and leaves. Okay, it leaves the plant through pores in its leaves into the atmosphere. Has anybody ever played Barrel Full of Monkeys? You try to like hook as many little plastic monkeys as possible? No. So Barrel Full of Monkeys is an old-fashioned game. You try to like hook as many monkeys as possible to get a chain of monkeys. That always reminds me of this idea of like water molecules hanging on to each other through cohesion. And so as one little water molecule pops out of the pore or the stomata in the leaf, it's got another one that it's hooked to that it puts into place. And so as a water molecule is being pushed into the roots, you can think of another water molecule being pushed out the top. And so this idea of cohesion, where the water molecules are hanging on to each other, and adhesion, where they're clinging to the little capillary tubes in the plant, allows for this process of transpiration to happen. And if you take a little plastic bag and you put it around a leaf out in the summertime, you come back the next day, you will have water in that little plastic bag that has moved from the soil out of the leaves. Now, my question for you is this, and I want you to please pay attention and participate. Which spheres are interacting in this case? Turn with your pair share partners and talk to each other. Which spheres are interacting? Ready, set, go. This isn't permission to go talk about whatever you want. I'm asking you to talk about what we're dealing with here. All right, 3, 2, 1, and we are done. Which spheres are definitely interacting with each other? Nope, I'm not counting on you. Which one? Hydrosphere for sure. That's what's moving. Yep. Atmosphere, because the water is moving from the plant into the atmosphere. And then the last one. Nope, not you. Which one? Biosphere is the plant, absolutely. So we've got biosphere, we've got hydrosphere, we've got atmosphere, and there's one more. Geosphere. Geosphere is the soil. So we're going from the geosphere through the biosphere into the atmosphere, and what's the thing that's moving?
Hydrosphere.
The hydrosphere. So it's all 4 spheres that we see at play in this particular example. Ooh, that's a good essay question for an exam.
I'm sorry, what now?
You have your exam next Wednesday. All right, so then I need you to put that away. If, again, you have finished your lab conclusion, I need it up here, please. Or slide it underneath the door by the end of the day so I can grade them this weekend. We are now going to go ahead and play a water cycle game. If you could please get out the piece of paper that you picked up on the way in, I would greatly appreciate it. Because we're going to have 15 minutes to move through this game. And I think we have no problem at all to do that. Logan, look at me. Logan, look at me. Do you want to go to the nurse? Patty?
Yeah.
You want to go to the nurse?
No.
All right, my dears. Water makes up 75% of the surface of the earth and can be found all over the earth. While all spheres interact, Water is considered the lifeblood of organisms in the biosphere, right? It's all about the biosphere, unfortunately, on our planet because we're part of the what? Biosphere. So we're really focusing on how all of the other spheres interact with us. So the biosphere in which the nutrients are distributed and waste products are removed, and we can't do that without water. There are 6 categories of water on Earth, including salt water, groundwater, which means this is water under the ground. So if you tap into a well, you're pulling water out of the ground, that's groundwater. Fresh water, lakes and rivers, ice caps and glaciers, and then water in the soil, and then water that's in the air. So we're going to go ahead and first look at this model that we have right here. We're going to look at a model, and 1,000 milliliters of water, or 1 complete liter, represents all the water on Earth in our model. So let's go ahead and start with the word all right here. Come on, all. So in our model, all of the water on the Earth is represented by this. I'm going to go ahead. Can you see the blue okay, or should I change it to red so it really pops out?
I can see it.
Red? One person said red. Is there anybody that can't read red? Some people are, really?
Yeah.
For serious?
Yeah.
It's all right, if he says it, I have to believe him because I trust him to not lie to me. All right, so a model, if we're talking about what a model is, and we've dealt with that lots of times in here, a model is what? A model is what? Yeah, Rebecca.
Like an example?
Yeah, an example. What's another word we could use? Go ahead, Will. Like a representation, a replica. I'm going to go ahead and use model. Model would be like unlimited. I'm going to say example because that's what Rebecca gave us. So it's a limited example or representation or replica of an object used to help us do what? Yeah.
Understand.
Yeah, understand, learn, whatever you want to say. I'm going to say understand right here because that's what you said. So it helps us understand its structure or how it works. So in this model, we're going to start with 1,000 milliliters of water. That's what we're starting with. Now, out of that, Alex, if you can't control yourself, kiddo, you got to go because I got a job to do, and right now you're getting in the way. I want you right now, out of that 1,000 milliliters, how many milliliters are going to represent the salt water on the planet, and how many milliliters are going to represent fresh water? Turn with your pair-share partner, ready, set, go.
500.
Just guess. What do you think? How much of that is salt water? How much of that is fresh water on our planet? Make a prediction and write how many milliliters of each right here. You make your prediction right there and write them in. Write them in right here.
I think there's salt water.
5, 4, 3, 2, 1, and we are done. I will tell you, as far as salt water, out of 1,000 milliliters, 972 milliliters is all salt water. Did anyone come close?
I came to 900.
I said 980.
Wow, that's really close.
Said 950.
Which means that only 28 milliliters is left for fresh water. Why is that important to us? Yeah.
We drink fresh water.
Yeah, we drink fresh water. So in our model, out of 1,000 milliliters of water on the planet, only 28 milliliters are available for us to sustain our life and also lives of other animals on the planet. That's not just for human consumption. So now we've got, let's bring that 28 milliliters up here. That's all the fresh water on the planet is 28 milliliters. Now let's divide that 28 milliliters into how many do we think are ice caps and glaciers? What do we think? 6? Anybody have any guesses?
12.
It's 23.5 is ice water. Now, what's the problem with ice?
Can't drink it.
Can't drink it. It's not easily, readily available to us. To us. I'm talking about like the polar ice caps, North and South Pole, big, huge glaciers. That is stuff that we can't easily access. So then groundwater, this is the stuff that's in the ground, is about 4 milliliters. Now the rest of it is going to be broken up into our lakes and rivers and our soil and air. Now what they told me, right, because this brings us to like, I don't know,
0.5.
73, what does it give us to?
27.5.
27.5, so we only have like 0.5 left to split into them. So when you look at that half a milliliter is broken out into 2 drops, not even a milliliter. 2 drops are gonna be in our lakes and rivers, so 2 drops. And then 1 drop is going to be in the soil and air. So just 1 drop. So that half a milliliter is broken out into 2 drops are here and 1 drop is there. That's not a lot. Were you surprised at any of the amounts? I was surprised to see how little fresh water there is on the planet, and then how little bit of that fresh water is not locked up in ice. Yeah.
Well, I wasn't really surprised about how much salt water there was compared to the fresh water, because I knew that 97% was salt water.
Salt water. Do you think that we need to conserve water?
Yes.
I think so. I think that we need to conserve water. You can put yes or no, whatever you want in here, but I feel the need to conserve water only because we have very little fresh water in the ground and in our lakes and rivers for us to go ahead and use, right? And we use a lot of it. Do you know where most of our water gets used, especially in our state?
Car washes.
No,
Crops.
agriculture. Not car washes, agriculture in Iowa. So most of our fresh water goes right towards agriculture. All right, so then does the amount of water on the earth ever change?
No.
No, it's a closed system. Just like your ecosystem bottles, it's a closed system. You need to know that. Please write that down. It is a closed system. You do need to know that most of Earth's, let's write the word fresh water, because it is not just water, it's fresh water, is found at the north and south poles in the form of ice. And again, it is locked in ice. It is not easily accessible by us. It's important to know that the amount of water has stayed the same over time. However, the form, or what's usually called the state of water, meaning if it's in a solid, liquid, or gas form, is always changing. So it's the form or the state of water. This is what's called the water cycle. The water cycle has no start and no end. It's constantly moving just like the rock cycle is. Well, I'm worried that you're not, that I'm losing you, bud. Does anybody know what the driving force of Earth's water cycle is? What? Where's the energy come from to make it move? That's right, it's the sun. The sun is the driving force. It's the energy of the Earth's weather. I want to write that down because the water cycle is a huge part of weather, or weather is a big part of the water cycle. And the sun provides the energy that powers our water cycle. So if you could please turn the page, I would greatly appreciate that. Mine's Kitty Wampus, sorry about that. But this is us going to be on a journey, and I believe that we did the same thing. I'm not really sure what game we played, but what game did we play where we rolled the dice and moved from place to place?
The sphere game.
The sphere game, okay. So what we're going to do is we're going to play that same thing, but you're going to be a droplet of water, and you're going to be moving from place to place around the classroom. You might be in the clouds, you might be in the glaciers or the river by the fish or the lake or wherever. Today we're going to explore the water cycle, or the path water takes as it moves around our planet. As you do so, describe how a water droplet moves from one location. This is the process. Remember those arrows? That's what it's going to be. Your starting point. I don't care where you start because you're all going to be going to different areas. So you can start wherever you want, and everybody individually is going to roll a dice, and then you're going to go someplace different. Okay, so you're not following one person around. But your starting point, I want you to go ahead and choose a starting point now. Let me see where I can go ahead and give you a starting point. If I can give you all of them, it'd be great if I could bring them up. I don't know. Pick a place. You've got river, glacier, lake, groundwater, plants, animal, ocean, soil surface, or clouds. Everybody pick a place and write that where it says starting point on your paper. Yeah, where are you looking for? What? Did you drop your pencil?
But can I go back?
Yeah, go quick. So everybody write starting point right where it says starting point. You're going to go to there, and the first thing you're going to do is roll the dice, and you're going to move to your first location. So you're going to say new location is wherever you go, right? And then you're going to look at that starting point. For example, if I'm in the clouds and I roll the dice, can you move this way, bud, with the... So if I'm in the clouds and I roll the dice, and let's say I get a 2. If I get a 2, it says I'm going to the glacier. So I look at this piece of paper, and I look for where it says glacier, and it says water falls as snow onto a glacier and becomes part of the glacier. I write that right here. I write my new location is glacier. How am I going to get to the glacier? Just by looking at what it says I need to do down here. This is how I got there. That's the process of how I got from clouds to glacier. And then you move to the glacier and you roll the dice again. I'm going to give us 15 minutes to do that. When you are done with that, you'll notice that you've got a vocabulary section right here. I have posted the link for vocabulary slides on Canvas, so you can open that up, and then it'll give you information as far as what the words are, matching the pictures, and then a description that you can write down. Does that make sense? So you're going to do this, come back, open up your Chromebook, and then get the definitions. The last part says, give an example of water moving through each of the Earth systems below. So we've got the picture of the water cycle of you moving around. You're going to take information from what you collected on your journey, and you're going to fill that in. That's going to help you on your exam. So I don't care where you start. You're going to roll the dice and move. You have 15 minutes to complete this, please, and your time is going to start now. If you roll and you stay where you are, that's where you write down the next one. You just keep writing that down. Don't skip it, just keep writing it down. All right, for those people that are at home, I put an interactive game for you on Canvas. I will bring that up and show you what that looks like. All right, so here's an interactive game for those of you that are at home. You've got dice that you can go ahead and roll right here where it says dice. You click on it, it'll tell you where to roll, and then you just follow the directions and you play the game at home. So that's for you at home, for those of you that are absent. And I hope you have a good weekend.